Well, hello everyone. Welcome back to Adrian's Digital Basement 2. On today's video, we're going to be talking about sound cards, specifically PC sound cards. This is an AW64, which we're going to be looking at. And I want to upgrade the RAM on this, which it only has 512K, to the maximum, 28 megabytes, using this. Well, actually, not just one of these cards, but one of these cards and one of these cards. Obviously not all at the same time, one at a time. Okay, so what are we looking at here? Well, this is the Rhapsody 28 megabyte edition, the MIDI Forge by Alex over at Bits and Bolts YouTube channel. Alex went ahead and sent me a few different versions of this. So this one obviously spells out AW using the RAM chips themselves. This is another 28 megabyte edition of the card, the Sonata Revision 2. There's Alex's channel name, a URL, and a QR code, which you can support his work. And Alex also sent me along this one, the Minuet, which is only an 8 megabyte upgrade for circumstances. Now, Alex has made a whole bunch of videos on his channel, which of course I'll link down below, on testing and designing all of these RAM upgrades. Apparently, there was a 28 megabyte upgrade offered at some point in the past, I think, but it's impossible to find these days. And if you want to use a card like this with full amount of memory, 28 megabytes, which I guess is the most the EMU 8000K, I think it's called, that's the synthesizer chip on here, can directly address. Well, your only option these days, I think, at least reasonably, is to get one of Alex's modules. Now, what's cool is these are actually open source hardware, so you can make these yourself. And I think everything that's on here, pretty easy to get. You have RAM chips, which you can take off old memory modules, off old SIMs. There's a PAL that handles the RAM addressing, and I think a few buffers. I can't remember exactly what these small surface mount ICs do on here. Now, this AW64 is just one of the basic versions. I think it was bundled with a Dell or something like that. I don't even know where I got this. These are very common and very plentiful. This has 1 megabyte of sound font ROM built in. So those are the instruments used for normal wavetable operation. But the RAM, which only has 512K on this board, some of these have 1 megabyte, I think. Some are even 4 megabytes. This allows you to load your own sound fonts into that memory. Now, generally you do this through Windows. There's a utility to do that. And then anytime you play a MIDI file, instead of using the built-in 1 megabyte sound font, it will use what you've loaded into RAM. Well, clearly 512K, not really that useful. But obviously, if we've upgraded this to, say, 28 megabytes, then you have a lot more room available for those sound fonts. And if you play a game like Doom or Quake that uses the MIDI synthesis on these cards, the wavetable synthesis that is, then your different sound fonts will change the way that that card sounds quite dramatically. Another thing you can do, which I'll demonstrate and I've shown a bunch of times on the channel, is you can use Cubic Player in DOS, which happens to be a mod file player. And it does support using the wavetable synthesis on these cards to allow you to play multi-channel mod files even on slow computers. And the PC that I have on the bench is my 36SX system right now, and I just was doing a little bit of testing before this video started with this particular sound card, which happens to be, if I pop this out, this is a Sound Blaster 32 card. So very similar capability-wise to this later card. This is just a very cost-reduced version. This uses the EMU 8000 wavetable synthesis chip as well. EMU is a synthesizer company. This board, on the other hand, only allows up to 8 megabytes of RAM installed. Or maybe you can use 16 megabyte modules and you can put 2 of them on and then get 28. I'm not too sure. I don't have any of those modules handy, but these are 4 megabyte modules. So this card currently sits at 8 megabytes of memory. So I was testing this in this computer using Cubic Player, and even though normally a 36SX is not fast enough to play multi-channel mod files, like maybe you could get away with a 4-channel playback, maybe, but I was able to easily play 32-channel, 40-channel files on this card without any issue. So I thought that was a good test for seeing if we could play those same files on this card. Try loading a larger file, something that was bigger than the 512K memory sample buffer would be here. Then hopefully we'll get an out of memory error for this card. And what we can do is install one of Alex's modules onto it, and then we should be able to play those larger files. I also have some sound fonts set up in DOS because I don't have Windows on this computer at all. So we could try loading some of those into here as well. And I think they're like 4 megabyte sound fonts, which obviously will not fit in 512K. There's something else Alex sent me, and it's one of his MIDI Forge modules. As far as I'm aware, this is a wavetable expander, so this plugs into a wavetable header on a sound card, like a Sound Blaster 16. And using a Raspberry Pi Zero, along with this I2C DAC module, a little OLED screen, a few buttons, I'm quite sure this allows you to use wavetable synthesis on the Raspberry Pi. So it emulates wavetable synthesis, and it can emulate full Roland MT32 as well. And because it's all a digital signal going to this DAC, which is, I think it's 96 kilohertz, 24-bit DAC, something like that. So it routes the audio back through the sound card. The sound quality should be quite good on this. But that'll have to be for a different video because this little sound card that we're going to be testing with doesn't have a wavetable header at all. And it doesn't make sense that it would because it's got a built-in wavetable synthesizer right on board. Let's start by popping this card in. I'll hook up the audio and let's just see if this card's working, which it should be. And we'll try playing some files on here and see if they work. Now, I'll just mention that Alex's channel has tons and tons and tons of details on these sound cards, including links to GitHub repos, PCBWay projects, all sorts of stuff if you want to try making one of these yourself or getting one of these yourself. I'm not sure if you can buy these. Maybe on Alex's website, he'll link you to people who are making these. But of course, if you're in the United States, we're now in this whole time when tariffs and people aren't shipping to the US and stuff. So yeah, I've had this for a little while before all of that hit. That's why I was able to get these from Alex, who incidentally lives in Dubai. So you see everything is initialized here for the sound card. I am using Unisound, and that's what the PMP setup thing is at the top there. That's configuring this card. Everything is pretty standard. The MIDI output of the card, which if you plug in a MIDI cable, would be 330. That's the I/O port. The wavetable port, which talks directly to the EMU, is 620. And then these other utilities like Diagnose and Mixer Set, that's just Sound Blaster utilities themselves, setting up the volume and stuff like that. What's nice about Unisound, by the way, is you do not need to put stuff in the config.sys. It's all auto-exec, and normally the utilities for Creative Sound Blaster cards require you to put stuff into the config.sys, which is kind of annoying, especially if you are trying to change sound cards a lot like I do, which is why I like Unisound. But what we do have is the Diagnose utility. Let's run that. And this should tell us how much RAM is on this card right now, just to confirm and double check. There it is. DRAM size, 524,288 bytes. It can test the RAM. We don't need to do that because I'm pretty sure the RAM works. I have a tick mark on the card, which tells me this card works. Let's just get through all of this. Okay, here is our regular test here. Now I do have the audio hooked up and it's recording it on OBS. I'm just checking to make sure it is recording. So I will not talk and I'll just be able to play the direct capture from the card.
8-bit testing. 16-bit testing.
Okay, so this is weird. I'm trying to play synthesized music and it says, well, it just doesn't work. I don't know why. That's weird. Could be that this Diagnose utility that I'm using is too old. Notice it's for a 16-bit audio card from 1996. I think this card probably came out after that. Well, no big deal. I should be able to just play a MIDI file using DOS mid. I have a little batch file to start that up, but it should use the sound font in the card here. And let's just see it's using the AW port 620 hex, which should talk directly to the synthesizer. Okay. Okay, so that totally worked. What we were hearing there was absolutely the wavetable synthesis with the Creative Labs sound font that's built into ROM. It sounds identical to this card. They both have the same exact 1 megabyte sound font, as far as I'm aware at least. Okay, let's run Cubic Player. Now, Cubic Player is configured to use the wavetable synthesis. That is using the EMU 8000 chip. There it is, Wave Blaster or Sound Blaster 32, that's what it thinks it is, but it's all compatible even with these later cards. And first I'll just start with this file here. This is like a chip tune, so the whole file is only 57 kilobytes or so, 64 channels though, impulse tracker file. This would not be playable with the 36SX without acceleration with wavetable synthesis. So Gravis ultrasound like a PicoGUS, no trouble playing this as well, but this should be able to play it. Yeah, so playing perfectly. Let's try something else here. These are just tiny files, so obviously these are gonna work. So there's many channels happening here. I don't think it's actually using 64 of them, but you can even go to a DOS shell which is not something you'd be able to do on a 36SX without the acceleration of this card. So this totally works, which is awesome. Oh, as soon as I tried to go to this high res mode though, it did freeze. And I think because there's just too much going on screen for the little 36SX, and it seems to have hard locked. That is not the sound card, that is just this computer is not capable enough for this high res mode. While I wait for the computer to reboot, I will mention that Alex also sent me this awesome Dubai chocolate cake bar. Kind of cool. The flare. Yeah, it looks good. Looks, you know, chocolate bar with some pistachio. I'm probably going to get a bunch of chocolate in my teeth. Yeah, that tastes really good. The pistachio was really light and fluffy. I love pistachio. I love chocolate, so that's a great combo. And there's a guy who owns a food cart here in Portland, and he actually is from Dubai, and he makes a bunch of cool stuff like desserts and things from Dubai. And I ordered this sort of cup thing, had some fruit in there, chocolate, pistachio layers, kind of these light crispy layers, sort of reminded me of the chocolate bar. Really good. Okay, system is rebooted. Let's enter Cubic Player again. And I'm going to try to load a file that's too big for the amount of memory that's on this. And let's see what that does. Now, one thing I noticed with the other card, even though the other card has 8 megs of RAM, is I can only load files about 1.5 megabytes or so into there. Anything larger, Cubic Player crashes. Now, this might be because this only has 8 megs of RAM on the system itself. There's only 8 megs on the motherboard. Maybe it needs more to uncompress and whatever, deal with the files, but it sort of crashes out with a core dump or sometimes other generic errors. It doesn't really tell you a whole lot. But I did write down a few files which I know work for sure. And one of them was this XM file, breaks8.xm, which is breaks from Narvik. And you can see that it's 30 channels and it's almost 2 megabytes. And this does play without issue on the other card. So let's try it on this without the RAM expansion. My assumption is it's going to tell us we have not enough RAM. It always takes a while to kind of process and load. This is a very slow computer. It is running at 40 megahertz, but that is still way too slow. And yes, it crashed. And actually, this looks a lot like the crash that I was getting loading the larger files. So I'm not sure if the issue with it crashing on the other card with the other larger files was due to the fact that the card didn't have enough memory, reported memory. I'm not sure. The only thing I can tell you is when we load this, let me hit pause, is it will detect the amount of memory, and it does it properly with the other card. So I'm trying to point to it. Sound Blaster 32, it says port 620M512. That's the amount of memory. And on the other card, it lists 8192. So it definitely saw all 8 megabytes as did diagnose, but for whatever reason, it would crash on the larger files. So if we upgrade this card, like say with this 28 meg one, then we should be able to play all the files. I don't know, let's just go for broke and install this really awesome looking white card first. So obviously I have to be careful installing this correctly. So I want to make sure that everything is lined up top down, so nothing is offset, and same that way. Okay, we'll give this a good little push. Okay, and let's see what happens when we turn this on. We'll let the magic smoke out. Hopefully not. I'm sure Alex has already tested these on cards, but who knows? This is a CT4520, by the way. Just I didn't mention that earlier. Okay, the system is running. Right, so Unisound does not show how much RAM is available on the card. I remember seeing on Alex's videos, there were some idiosyncrasies, like if you have a 1 meg card, then not all the memory is available. There are a couple sense pins on the connectors, which the PAL uses to map the memory correctly. Those sense pins are set using some fixed resistor values that are on the card itself. And then that tells the RAM expansion how to map its memory back into the main system. And there it is. Yeah, 28 megabytes. Awesome. I'm not going to do a test because it's really slow. Let's run Cubic Player again and try that file. There, memory 28672. Heck yeah. No, right, so first thing I'm going to try is I'm going to try to load this B-Flight impulse tracker file. This always crashed with the other card, even though the other card 8 megabytes would obviously fit. Let's see if it still crashes. Oh yeah, it still crashes. So that is not anything to do with the amount of memory on the sound card. Might have to do with the system memory, or Cubic Player just can't handle files that big, which is quite possible. But let's try breaks from Narvik, which did work on the other card, and hopefully will work now. We have this 28 meg module, which obviously is way more memory than is actually needed. 8 megabytes is probably realistically the most you would ever work or need, and there it is. That doesn't work. I'm trying to show the oscilloscope. Too slow. I just wanted to show a little bit more information about the file that's playing. It's in the instrument list, which is what we're looking at here. All right, well, this track, obviously working well. Oh yeah, it's playing with more tracks now. No issues. Okay, here's another one that works. Well, I wrote down my list that it works, fire.xm. Now the audio quality was perfect. There were no issues whatsoever. It was just like on the other Sound Blaster cards. That kind of tells me that this RAM expansion is working perfectly. And this one's playing as well. All right, here's another file. It's called The Occasion. It's by Skaven. And one of the issues with Skaven's tracks, a lot of them, is they can be flagged for copyright. So this whole section might be deleted from the video if this gets flagged. This one's 1.5 megabytes, and it did play without issue on the other sound card. I switched the video mode again and it did crash. It could be a problem with this Cirrus Logic video card. It was actually playing for a little while, then it crashed. All right, well, we know this Rhapsody 28 megabyte card is working perfectly, so that is freaking awesome. Very cool. Why don't we try this one here, the Sonata Revision 2. As far as I'm aware, there's no difference between the Rhapsody and the MIDI Forge Sonata, just physical size difference. And I guess one of the main things is it's using higher density RAM chips, which may or may not be easier to get than these. I'm pretty sure you can steal these off of a sim, but I'm assuming those can as well. I see this has a voltage regulator on it. This one does not. That tells me that these are probably 3.3 volt chips and they're probably 5 volt tolerant, which requires, I guess actually there's 2 voltage regulators on here to run these chips. So the BOM is a little bit different, but this one has the cool look to it at least. Now, it still detects it as 28 megabytes here for Cubic Player, so excellent. So the Sonata is working well as well. And what's really cool here is we know that these larger files don't play on this card, right? Or they wouldn't if we were just running with the original 512. So we know that the RAM expansion board, all the select logic and everything that's interfacing it to the sound card is working. Otherwise, we wouldn't be able to play any of these files here. Like here's Fast City, 700K, it's still more than the internal buffer. I just crashed the computer again by pushing the X key. I keep trying to exit the program, and the odd thing is the music is still sitting here trying to play. So the synthesis engine on here is still running. It didn't properly shut down the card. It will obviously, yeah, now it's quiet because it ran the setup utility. Just kind of shows that the card is doing all the heavy lifting just like a Gravis ultrasound card would do. Now, one thing that's funny is, like, even I question this, is like, why, if these cards are like the Gravis ultrasound in their synthesis capability, why weren't these more popular during that time when the Gravis was really in demand? Like, I think this card here is from 1995, so it's kind of a similar era to the Gravis. Maybe it came out a little bit after it, but as far as I'm aware, it's the programming API interface for this chip or this EMU stuff is really obtuse and difficult to do. And the Gravis was really easy to program for, which is why all those demos and things are written for, but like nothing is written to use this stuff. Of course, once you got to Windows, it didn't really matter anymore, like Windows 95, because you had a driver from Creative Labs that would handle all of that stuff, and then your software could just talk to it directly. Although, I guess everything was just using the regular sound fonts and wasn't even trying to customize the samples like you were always doing with the Gravis Ultrasound. Now, just in case you were wondering about Cubic Player and the wavetable synthesis really being necessary for a computer of this speed, let's go and edit the INI file here, and I'll just turn off the wavetable synthesis. You do that by commenting out this line, dev w Sound Blaster 32, and we turn this one back on where the mixing is happening in software. Now, Q, mix, and F, I think those are different ways of mixing, with F being floating point. And this does have a math code processor on here, so we could try that. One is like a fast integer method, and the other one is, I don't remember the exact differences, but we can switch them once we're in Cubic Player itself and try different ones if the performance is horrible with one or the other. And this is just going to use the sound card as a Sound Blaster 16, so 16-bit sound card. It will not use any of the wavetable synthesis capabilities built into it at all. First, let's try this file here, rows, 57 kilobytes, but it's only 4 channels, so it should be pretty easy. Let's see if it can actually play this, at least with whatever mixer it's using. Okay, well, there's sound, but... oh no! Okay, I paused it because if we just try to go to the file selector, that will be way too slow. To switch the mixer, we go to the little @ symbol here, and we go to devices, and these are the mixers. So I forgot which one I was using now, but I think it was Q or nothing. So let's try the FPU mixer, and let's see if that makes any difference whatsoever. So now we go back to the C drive, and I think we were playing rows. Let's try that again. Remember, there's only a 4-channel file, not even any one of these higher channel files. Is this any better? Let's see. Doesn't look like it. Nope. It can barely draw the text screen. You figure that's like super easy. Let me turn off the analyzer. I mean, that was obviously some amount of work to do that. Wow, I can't even do stuff. Okay, I hit pause. It's much worse playback-wise. Well, let's try switching to, let's try this one, the one without the Q. I think the Q means maybe quality. Well, either that or quick. I can't remember. Okay, well, it's playing. Okay, that's really not working. Let's try this 25 channel one just to see it really struggle. I'm trying to escape and it will not even leave the program. Okay, I'm gonna turn the speaker down. Oh, I was finally able to exit. That did not work properly. So you can get an idea that it really, really is using the wavetable synthesis to play these files, because this computer and this player is just not optimized enough to play these files. So let's do the final swap. I'm gonna switch over to the MIDI Forge Minuet, 8 megabytes. I wanna see this one work. I mean, I'm sure it's gonna work fine. And to be honest, if you're gonna make one of these, or, ow, this part of the card right here, it's really hot. See how like the board is slightly discolored right there? That part gets really warm. Not so much this one, it's that one. And you can feel it through the back of the board. Yeah, right there. Anyhow, I'm gonna pop off the 28 meg MIDI Forge. Now, what I was just saying is that if you're just using DOS stuff like I am here, without a doubt, 8 megabytes is more than enough. So if you're gonna make one of these up or get one of these, you will be fine just using this 8 megabyte card. There it is, 8192, exactly the same amount of RAM on my Sound Blaster 32, which is cool. Now I can just try this file here, for instance. On the case, this will not work without the RAM expansion card, and it definitely is going to use the RAM expansion card to play back the sampled audio. I accidentally hit the X key again instead of escape to quit, and it went to that high-res text mode and then it crashed. So I was gonna say, one caveat of these RAM boards, by the way, is that there's only a small amount of time when you really need wavetable synthesis. And what I mean by that is in the 3.6 era, 4.6 era, there's just not a lot of horsepower on the CPU side to do all this high bandwidth mixing of all these audio channels, 16-bit audio, all that type of thing. It takes up quite a bit of CPU power, which you could see because when I tried to play this through software, it really didn't work. But if you're just trying to play mods as an example and you're using Cubic Player in DOS, these sound cards work perfectly to do that if you have a faster CPU. If you have a Pentium, then you can pretty much play anything and use software mixing. 16-bit works flawlessly. There's no issues with a Pentium mixing all those channels. I think the horsepower available to a Pentium is so far ahead of, say, this 36SX, even though, I mean, what were we talking, like 10 years later when the Pentium came out? But the leaps and bounds were so dramatic in horsepower of the CPU that, yeah, software mixing became the norm, and that way you could just use a regular sound card, Sound Blaster 16 or whatever, and you didn't even need any of this MIDI wavetable stuff. As long as you had enough memory to load all those samples into your RAM, it would just mix it and then just stream it as 16-bit audio right to your sound card. So as I said, for playing mod files, if you're going to use an old computer like this, yeah, you're going to need wavetable synthesis. So a GUS, like a PicoGUS, or a real Gravis ultrasound, or one of these cards with one of these RAM expansion cards, so you can load those modules and play them properly. But if you have a Pentium, you can use any of these sound cards, and you just don't even need the wavetable synthesis. You can just do it all in software, and it totally works. And of course, it goes without saying that if you just get something like a PicoGUS, this card basically emulates a Gravis ultrasound perfectly, plus a bunch of other sound cards perfectly. And with the Gravis ultrasound, I forgot how much RAM this thing has on it, 8 megabytes, maybe PS RAM, I think it's called. So it's able to load the samples from Cubic Player directly into this, and then it's using the Gravis ultrasound. And of course, you can play everything else that Gravis ultrasound supports, like all those demos and whatever early games, all work perfectly through the PicoGUS. So this also has the same DAC module that's on this MIDI board. So really high quality audio output on here, and MPU 401 compatibility, true MPU 401 compatibility. So you can plug your Roland MT32 into this, your sound canvas into this, and it just works flawlessly in MS-DOS, absolutely perfectly. And finding a real MPU 401 card is like hard and really expensive, and there's some clones I think now, but they're all expensive, and this thing is not expensive. And you can make one of these yourself, open source hardware, open source software. Can't say enough good things about the PicoGUS. So not to take away from Alex's work with all these RAM boards for these Sound Blaster cards, there's something to be said about Sound Blaster cards and their broad compatibility. Things just generally work really, really well with them. And of course, adding one of these cards that Alex has made just upgrades the RAM on them, giving you all that extra sample memory if it can be used, which I can't seem to use it with Cubic Player here, but I'm sure with Sound Fonts, it will work with Sound Font 2 files, which are only Windows sound fonts. Definitely, you can load those large sound fonts into these, and then when you play games like Doom, Quake, whatever, that's using MIDI, general MIDI, it's going to sound different, better, maybe. I'm sure it should. Only 1 megabyte of sample memory on the ROM on here. When you upgrade those and you load like a 15 megabyte sound font, which they do exist, then all those instruments should sound potentially a lot better. Now, speaking of the sound fonts, by the way, there are sound fonts you can load in DOS into these cards, and with this RAM expansion card, we can check that out. So the way this works is we have a SF bank directory, and there's a file here. An original one was called synthgm.sbk, 34 kilobytes. I don't even know what that is, but if you load general MIDI emulation, that's the file that gets loaded. My assumption is that file simply points over to the 1 megabyte of ROM on board, and it's just using that. But I found a couple other SBK files. SBK files are SoundBank 1.0 files, which is what this can use in DOS. This is a driver limitation. This is not the card. Windows uses SF2, SoundFont 2 files, which are more capable, more common, bigger. There are larger ones and more of them. But I found 2 of these SoundFont files. So there's SCC1T2 SBK. And I copied that over the synthgm.sbk file. So that's why there's 2 files of the exact same size. And then you run util and you do emulation gm. And this will turn on the general MIDI emulation, which means that plain MIDI files won't output the MIDI through the connector on the back of the card anymore. It's just going to use the internal synthesizer, the wavetable synthesizer, to generate the MIDI music itself. Now, this is a different I/O port than the 620. That's the actual AW synthesizer direct. It actually uses, I think, 320. I think is what it's configured to. Whatever the original external port was configured to is what the emulation is configured to. So if we go back to DOS mid, so I have a couple different files here, and one is play 300. Now, if we look at what this file is, it's actually going to use 330. Yes, MPU 330. So this is going to play my MIDI files that I have in the little M3U file there through the MIDI port on this card. And now the emulation is turned on using that almost 4 megabyte sound font file, so too big for this card's normal internal memory. Well, let's see what this does. Okay, so it's going to load just like it did before. Okay, so that was working. It just didn't sound very good. We can do the same play again, but we'll do it through the built-in wavetable synthesis of the card. So it's going to use that hex I/O port 620. So it's not using the sound font now, and it sounds a bit better. It doesn't sound great. I've heard better, like through a sound canvas, things like that. But it kind of tells us that the sound font is not great. And it has like weird hanging note bugs and stuff like that, which I think could be due to the DSP version that's on this card. I'm not 100% sure about that either. Right, so you could hear it sounded substantially different there, and I would argue that that sounded quite a bit better than that particular sound font. Now, one of the things that I have to put a caveat on is that the sound fonts, the 1.0 versions that I found, all seem to have been converted from sound font 2.0 back to 1.0, which is only something you could do recently because the format was never really explained or documented properly. And I have a couple files that I downloaded here. So SF2 are the actual sound font files. You notice that like one of them is 15 megabytes and another one is 27 megabytes. I don't know how good those are because we can't use those and I don't have a utility to do this conversion. Looks like someone wrote a conversion utility, but they never released it. I saw someone on Vogons talking about it and making some posts and uploading some of the converted files, but people were saying that the converted files didn't work correctly, they didn't sound right. But SCC1T2 is the one we just played a second ago that sounded not great, but not horrible, but not as good as the stock one. But there's this HL4MGM SBK file, which is 4 megabytes. It was a conversion from a sound font 2 file, which is the one that's right below it. I'm just going to move that file over to the AW utility directory, and I'm going to overwrite that file, and we'll try loading this one into the memory, which is only possible because this has the RAM expansion on it. Whoops, I accidentally just called it awutil, so that's fine. But we'll copy awutil dot on top of synth gm.sbk. I had a couple typos in there. We'll overwrite this. Takes a moment since this is a slow computer and it's using a compact flash card, so even handling 4 megabytes of sound font data takes a while. But here we go. It's loading as going to play MPU 300 or 330, which is the emulation mode. And let's see how this sounds. Bad, I think. Bad. There you go. Sounded different. I thought the percussion was actually a little bit better on that one than the other two, even the built-in stuff. But it had some hanging notes going on. Don't know if that's a problem with the sound fonts. I don't know if that's a DOS mid problem. I don't think it is because I've used DOS mid to play these exact files through the PicoGUS with the MPU 401 mode. Works perfectly. No issues with weird hanging notes or anything like that. So this is either a Sound Blaster problem or a sound font problem. I'm not even positive. But I am quite sure that if you played those files in Windows, it probably would work fine. I bet you there's a whole like a DOS problem and a whole Sound Font 1.0 problem. And it would be possible because we have these RAM expansion boards that Alex made. So that'll be something I'll probably play around with at some point in the future. I really do need to have like a Windows 95 test machine. I have Windows 95 installed on a Pentium machine back there. The problem is it's all sort of integrated in because that's the machine I use periodically hooked up to this monitor behind me. It's not something I can just put on the bench in front of me and I have to unplug all the cables. I need to get probably a compact flash card set up with Windows 95 so I can use that on the bench more easily with faster computers than this 3CSX. And that way I can do proper testing with stuff like this. And not to mention I would need to image the card. That way when Windows 95 invariably gets corrupted by putting some drivers on, I could just undo and just rewrite the card. Either way, I have to say this is a super awesome project that Alex came up with, creating these RAM boards. And if you haven't watched Alex's channel, I highly recommend it. Not only has he designed cool stuff like this, but Alex has done a ton of cool repair stuff on his channel as well, especially fixing Voodoo cards and other surface mount cards where these large flat ICs get some of the pins damaged from, say, e-waste recycling or just flexing of the board. And Alex has done some great troubleshooting where he just uses the microscope and figures out which pins are bad and reflows stuff and gets a lot of stuff working that way. And Alex being able to rescue those cards and also teaching other people how to rescue those cards is something I fully stand behind. So that's going to be it for this video. Thanks again, Alex, for sending this stuff in. I will definitely put some links down below if you're interested in any of this stuff, so you can check it out for yourself. Don't forget to check out Alex's channel. Huge thanks to my subscribers and my members and my supporters on Patreon. They make it possible I do all of this full time. I'm going to be in VCF Midwest coming up soon, but I think by the time you see this video, that will have already passed. So hopefully I saw you there. And that's it. So stay healthy, stay safe, and I'll see you next time. Bye.